So this is the quiz review, 2A quiz review. For each of the following, find the inverse. So remember that the very first step when you're finding the inverse is you take the x, just the x and the y, not any of the numbers, and you just trade their places. So this would be x is equal to 1/2 y minus 4, and then you're trying to get y by itself. So if you add 4 to both sides, and I'm going to put that after the x, you would get x plus 4 is equal to 1/2 y. And to get rid of a fraction, you multiply times the reciprocal. So we would multiply times 2 on this side and times 2 on this side. The 1/2 and the 2 are going to multiply to 1. So on this side, you're left with y. And over here, you distribute both sides. So you get 2x plus 8. And then remember, we would write this as f inverse of x is equal to 2x plus 8. For b, remember that this takes the place of y. So this is really y equals 3x plus 1. And so the very first thing we want to do is trade the x and the y, not any of the numbers, just the letters. And so we get x is equal to 3y plus 1. And then we want to get y by itself. So the first thing we want to do is we want to subtract 1 from both sides. So x minus 1 is equal to 3y. And then to get y by itself, we divide each term by 3. So x over 3 minus 1/3 is equal to y. So to write that in function notation, we would do f inverse of x is equal to x over 3 minus 1/3. And again, on this one, this is really the same thing as y, so you can replace that with y. So y equals negative x over 2 plus 5. And then again, remember, very first step is to trade your variables. Don't trade any of the numbers or signs, just trade your variables. So this would be x is equal to negative y over 2 plus 5. We can rewrite this one so that it's a little bit easier to see. This would be negative 1y over 2. So it's the same thing as negative 1/2 y plus 5. So again, we're going to get rid of the 5 and get rid of this 5. So x minus 5 is equal to negative 1/2 y. And then to get rid of a fraction, you multiply by the reciprocal. So we're going to multiply by a negative 2 here because we want the y to be positive. So when we distribute the 2, we get, or the negative 2, negative 2x plus 10 is equal to y. And to write that in function notation, f inverse of x is equal to negative 2x plus 10. Domain and range for the following graph. So remember that the domain is the x values of the graph, how far the x values span. So in this case, the arrows tell us that this graph keeps going. So our domain in this case would just be all real numbers. And the range in this case, because it starts at -4 and goes down, or sorry, starts at +4 and goes down, the range would be y is less than or equal to 4. Is it a function? So in order to tell if it's a function or if it's 1-to-1, we need to do first the vertical line test. So if we take a vertical line and we pass it across here, we can see that it is a function. And then to tell if it's 1-to-1, we do a horizontal line test. So if we take a horizontal line and pass it across here, we can see that it touches here and here at the same time. So that would not be a 1-to-1 function, which means that this would not have an inverse. Okay, find the domain and range of each of the following functions. So on x cubed, our domain is all reals, and our range is going to be all reals also, okay? The reason that it's all reals is because we don't have one of the mathematical problems that we talked about. And if you remember, the mathematical problems that we talked about were square roots and fractions. So anytime that you have a square root, the number that you get underneath here can't be less than 0. So whatever we put in for x has to make this greater than or equal to 0. So if we solve this, we know that x has to be greater than or equal to 3. That's our domain. And for the range, we know that if we put a positive or a 0, or sorry, a positive 3 or above in here, what we're going to get under here is 0 or above. And when we take the square root of a number, we can't get anything less than 0. So our range is that y has to be greater than or equal to 0. With your domain on this one, remember that whatever is underneath here, we can't divide by 0. So whatever makes this 0 cannot be a part of the domain. So if we subtract 4 here, we know that x cannot be equal to -4. Okay, it could be anything besides -4. It could be negative, it could be a 0, it could be a decimal, a positive fraction, but it just can't be equal to -4. The range can be anything except y is not going to be equal to 0, because there's no way to get an answer of 0 when you're dividing by a number. Unless your top number is 0, and in this case your top number is not 0, so you won't get a 0 in this case. On this one, the domain and the range have definite starting and stopping points. So the domain, you can kind of think about putting a box around it. Okay, so if you think about putting a box around it, the domain is the starting and the ending point. So in this case, your domain goes from -3, and it is not inclusive because this is an open circle here. And it ends at +1, and that is inclusive because it's a closed circle. Your range would be the y values, and these would both be inclusive. So the lowest y value is -4, and the highest y value is 0. So it goes from -4 to 0. This one's a little bit harder to see, but again, we have definite starting and stopping points. Maybe try another one, this one. Okay. So the domain in this one, remember the domain is the x values, and your domain this time is going to be inclusive on both ends because there are closed circles. So you can put the bar underneath on both of those. So it stops at -3, or starts at -3, and then it stops at, let's see, 4, I believe this is. And then the range on this one, it's from the lowest to the highest, remember, so this would be -3 to +2, I believe that is. And you're done with that part. Okay, so on this one we just want to find each value. So we have some that are composition of functions, some that are inverses. F of 5, remember this is the input and this is the function that we're going to use. So we're going to take 5 and plug it into the f function. So 2 times 5 plus 7 is 10 plus 7, which is 17. So f of 5 is equal to 17. Again, input, function. So we're going to take 5 and we're going to plug it into the g function. Okay, and then f of g of 2. So remember, we are starting on the inside. So the first thing we're going to do is we're going to put 2 into the g function. So g of 2 is equal to 3 times 2 plus 1, which is 6 plus 1, which is 7. And then we're going to take that answer and we're going to plug it into the f function. So we're going to do f of 7, which is 2 times 7 plus 7, which is really the same thing as 3 times 7, which is 21. So f of g of 2 is equal to 21. Okay, on this one, what they're saying is that if we take g of x and plug it into the f function, okay, so here's g of x, and we're going to take that and plug it into the f function. So we would have f of 3x plus 1, which means that wherever we see an x in the f function, we're going to plug that in. So 2 times 3x plus 1 plus 7. So distribute 6x plus 2 plus 7, and then combine like terms. So f of g of x is equal to 6x plus 9. This is just going the opposite way around. So f of x gets used as the input in the g function. So really we're saying g of 2x plus 7. So everywhere we see an x in the g function, replace it with this 2x plus 7. So 3 times 2x plus 7 plus 1. Again, distribute and combine your like terms. So 6x plus 21 plus 1 is 6x plus 22. So g of f of x is equal to 6x plus 22. So this, again, is your input. We're going to put it into the g function. So everywhere that we see an x up here, we're going to replace it with a c plus 3. So 3 times c plus 3 plus 1. Distribute and combine your like terms. So 3c plus 9 plus 3, 3c plus 12. So g of c plus 3 is 3c plus 12. Okay, remember what this means. This means that whatever is in here is going to go where your output would go instead of your input, okay? So typically, if this was f of 10, this would be our input and we would put it in for x. But what this means now is that we're going to put it where the f of x is and solve for that equation that way. So we're going to use the f function and we're going to say 10 is equal to 2x plus 7 and then solve that equation. So 2x is equal to 3, divide by 2, x is equal to, you can either leave this as 3/2 or you can change it to 1.5, it doesn't matter to me. Remember that an f and an f inverse cancel each other out and all you're left with is your original input. So over here, an inverse and a function cancel each other out. So really what we're saying is we want 22 to be the input into the f function. So f of 22 is equal to 2 times 22 plus 7, which is 44 plus 7, which is 51. All right, last one. Again, this is very similar to the last one that we did. This is telling us if the 2200 were in here, that it means that this is our input. If it's outside, what it's telling us is that we want our output to be equal to 2200. So this f of x is going to get replaced by this 2200, and we're going to solve the equation that way. So 2200 is equal to 3x plus 3, subtract 3, we get 3x, whoops, 3x is equal to 2197, and then divide both sides by 3. So x is equal to whatever 21 over 97 reduces down to or divides by. I'm okay with you just leaving it like that too. Same thing, okay? The f of x gets replaced with the 2200. This is what we want our output to be. It's not telling us what our input is. If it was our input, it would be inside the parentheses. So we say 2200 is equal to 4x squared minus 2. So we add 2 to both sides. 2202 is equal to 4x squared. We have to divide by the 4 first. So 2202 divided by 4, so this means that x squared is equal to 2202 over 4, and then take the square root of both sides. So x is equal to the square root of 2202 over 2, because the square root of 4 is 2. All right, there's your review.